this is a question about probability. It says the continuous random variable x has a probability density function f of x equals this. This is a piecewise function, but we notice that for x not in the interval from 0 to 1, f of x is equal to 0. So that doesn't contribute anything to the sum of the probability. So in order to find the probability, we'll only have to calculate the integral from 0 to 1 of f of x dx, and this is equal to 1, right? Okay, so for question part A, we need to find the value of k. So that's where we need to use this equation. So let's just plug in f of x into this equation, and that gives us integral from 0 to 1 of k over square root of 4 minus 3x squared dx equals 1, right? Okay, so in order to integrate this expression, we need to go to the formula sheet to find a standard integral. And actually this integral of 1 over root of a squared minus x squared dx, this is equal to arc sine of x over a, then plus a constant. Okay, so we'll be using this. But here it is a little bit different from the expression we are dealing with. So we need to convert the expression we're dealing with into the form that we'll be using. The only difference is that we have 4 minus 3x squared instead of a squared minus x squared, right? So the coefficient for x squared should be 1. So we need to factor out 3. So that would be 3 times brackets 4 over 3, the minus x squared. So in this case, a squared is 4 over 3, and we have this x squared here, right? Okay, so let's just write this under the expression. So that means we get integral from 0 to 1. Let's just, since k is a constant, we might just take it down and put in front of the integral sign. So that's k times this of over 1 over square root of, since we have taken out a 3, this expression becomes this, right? Equals 1. Here we can take out a root 3 at the bottom. So eventually we get k over root 3 times integral from 0 to 1 of 1 over square root of 4 over 3. Let's turn this into the squared form, so we can better compare that with this expression, okay? So that means we have 2 over root 3 squared, the minus x squared dx. So we know this corresponds with a, and x is here, right? And this is equal to k over root 3 times arc sine of x over a. A is 2 over root 3. Okay, then from 0 to 1. Next thing we'll be doing is we just plug in x equals 1 and 0. So that gives us k times root 3 times when x equals 1, so that's arc sine of 1 over this 2 divided by root 3, so that we just flip it, so that means 1 times root 3 over 2, so that's root 3 over 2, right? Then minus when x equals 0, okay, so x equals 0, so that's arc sine of 0. And this is equal to k times root 3 times, so arc sine of root 3 over 2 is pi over 3. and arcsine of 0 is 0. So eventually we have k pi over 3 times root 3, and this should be equal to 0, as this is the sum of the probability. We'll be looking for the value of k. So k is, we can multiply both sides by 3 times root 3, and then divide both sides by pi, right? So that gives us this. Okay, so that's the value for k. Okay, we can just put it here. We know that k is equal to 3 root 3 over pi. Okay. I'm gonna get rid of the notes so we have some room to do the next question. Okay, so part B, we need to find expected value of x. So the expected value of x is equal to integral of so from 0 to 1 of x times f of x, then dx, right? And so we can plug in f of x as well. So that gives us x times k, then 4 minus 3x squared dx. In order to integrate this, we need to use the u substitution. Let's say let u equals 4 minus 3x squared. So du is equal to negative 6x times du times dx, right? Since we have x here and we have dx, so what we need to do is to times a negative 6 and then divide it by negative 6. So we have integral of let's say negative 6x dx. Let's just put k outside, okay, in front of the integral. So we have this, and then divided by negative 6 times so this is u to the power of 1/2. Okay, we can wait a little bit for the boundary here after we figure out what is the value for d for u. So this is equal to k times integral of, okay, since this is equal to du, so let's just replace that. Du over negative 6, and I'm gonna put negative 6 here, and then we have u to the power of negative 1/2, u to the power of 1/2. So this is equal to k over negative 6 and times integral of u to the power of negative 1/2 du. And this is a very easy integration to do, right? Okay, so this is equal to k over negative 6, then integral of d. This should be u to power 1/2. But since we bring down a 1/2, so we need to get rid of that. So we need to times the 2. So that means we times the 2. Okay, let's just times the 2 here. Okay. And now let's figure out the boundary. So since x is from 0 to 1, so that means u is from, when x equals 0, u is equal to 4. Okay, when x equals to 1, u is equal to 1. So that means we have this boundary from 4 to 1. Okay, we're almost there. So 2k over negative 6 times u to the power 1/2, 4, 1. Okay. Next, let's just plug in. So we have 2k over negative 6 times, when u is 1, so 1 to the power 1/2 is also 1. Then if u is 4, so 4 to the power 1/2 is actually the square root of it, so that's 2. So here is -1, right? So eventually we have k over 3, and this is expected value. But since we already know the value of k, so let's just plug it in, so we get 3 over pi, then divided by 3. So that's the same thing as multiply by 1/3. And this 3 on the top and the bottom can get cancelled. So eventually we have root 3 over pi. Okay, so that's the entirety of this question 7.
Thanks for watching. If you enjoyed this video, please hit the like button and subscribe to the channel. If you have any problems, you can leave a comment below. I'll be glad to help. Bye bye guys.